Quite a nice additional math question on differentiating with exponential functions. So my function is y equals x e to the power of minus x over 2. And I need to find dy by dx. Let us not forget that between dx and ez times x times e to the power of minus x over 2. So I need to use a product rule. Take it in small steps, don't do many things at once, don't do two things at once. So I just apply the product rule. Plus x times the derivative of e to the power of minus x over 2. Now at the next step I'm focusing at how to differentiate each of these. So the derivative of x is 1, we get e to the power of minus x over 2 plus x times e to the power of minus x over 2. Remember the derivative of e to the power of x is e to the power of x. So the derivative of e to u, composite function, is e to the power of u times the derivative of u. So I got here e to the power of minus x over 2 times the derivative of minus x over 2. See, I'm not differentiating twice. I just do it in small steps. E to the power of minus x over 2 plus x times e to the power of minus x over 2 times minus a half. So it's e to the power of minus x over 2 minus x over 2 e to the power of minus x over 2. And now I need to bring it to that form. I'm told to show that dy by dx is this one. So what I see there, a bracket factorized, e to the power of minus x over 2 factorized, brackets 1 minus x over 2, which is 2 minus x over 2, which is the same as expression from there, 1 over 2, I just need to copy it, 1 over 2, brackets 2 minus x e to the power of x minus x over 2. Now next question asks me to find an expression for the second derivative. See, practically, the first question could sound scary, show that. Generally students are intimidated about such type of questions, but actually they are not difficult. At opposite, they are easier. Practically the answer is given. And if when differentiated I don't get this answer, I will take this correct one in order to solve the next question. So practically it's a hint for me if I get right or not, so that I don't carry my eventual mistakes to the next step. So even if I don't manage to prove dy by dx in that form, that's the form I'm going to take forward to the next question. Okay, that's my dy by dx, and I need to find the second derivative. How am I going to differentiate this? Again, product rule. 1 over 2 is a coefficient. I can leave it in front. So it's 1 over 2 times the derivative of this. And here, if I'm using the product rule, this is going to be the derivative of 2 minus x times e to the power of minus x over 2 plus 2 minus x times the derivative of e to the power of minus x over 2. Which is going to give us 1 over 2, and now what do I have in brackets? The derivative of 2 minus x is minus e to the power of minus x over 2 plus 2 minus x times e to the power of minus x over 2 times minus 1 over 2, the derivative of minus x over 2. Now I need to rearrange it. 1 over 2 e to the power of minus x over 2, brackets 1 minus 2 minus x over 2. So it gives me 1 over 2 e to the power of minus x over 2, 2 minus brackets 2 minus x over 2, which is okay, actually I stopped and I made a mistake. I look back. I didn't carry this minus here, the next step and to the next step. Yeah, so I should have minus 2 negative 4 plus x minus 4 over 4 e to the power of minus x over 2. That's the second derivative. The next question says that the curve has a stationary point at M. Find the coordinates of M. Stationary point is where dy by dx equals 0. So remember that dy by dx was a half brackets 2 minus x e to the power of minus x over 2. Now e to the power of minus x over 2 cannot be 0. E to any power cannot be 0, and remember the graph of y equals e to the power of x. It doesn't touch the x-axis. Therefore, x must be 2. Y for x equals 2. My function, remember, was y equals x e to the power of minus x over 2. So y is 2 e to the power of minus 1, so 2 over e. So my point, I think it was called P, has a coordinate, it's 2 over e. Okay, actually I've seen that my point was called not P but M, doesn't matter. Now I am asked to show, so I know that P is a stationary point, find the nature of the stationary point. Since I have the second derivative, it makes sense to use it. Remember, my second derivative was, I'm going to do it actually both methods with the second derivative. The second derivative was x minus 4 over 4 times e to the power of minus x over 2. So the second derivative when x equals 2 is actually 2 minus 4 over 4 e to the power of minus 1. 2 minus 4 is negative 2, so this is smaller than 0. Therefore, point of maximum. The second method would be just to look at the sign of the first derivative around the point 0. So I'm going to do it on the next slide. Remember, the first derivative was dy. So practically I'm doing the same thing with another method, looking just at the first derivative. That was the first derivative. So at x equals 2, so for any x which is smaller than 2, 2 minus x is bigger than 0, right? So dy by dx for an x smaller than 2 is positive. Similarly, if x is bigger than 2, then 2 minus x is smaller than 0. So dy by dx when x is bigger than 2 will be smaller than 0. So if we think at x and dy by dx, at 2 dy by dx is 0, before 2 is positive, after 2 is negative. So before 2 we have tangent with a positive gradient, so the tangent to the positive gradients do like this. After 2, a tangent with a negative gradient, that's a negative gradient. So look at the shape, therefore x equals 2 is a point of maximum. Yeah, actually not x equals 2, but the point P of coordinates 2, and I think it was 2 over e, is a point of maximum. Same result as before.